I'm Joe Logue, and I'm the robotic and automation major.
I'm Tom Corin, I'm a robotics automation major.
And I'm Roman Chigatano, another robotics and automation major.
Hey, Joe.
And what we're doing here today is organizing bottles. We have half-full bottles, full bottles, and empty bottles. And the end goal is going to be empty bottles are going to go to this bin here with this robotic arm, drop into there. Full bottles are going to go straight down this belt here and drop into the bin at the end. Half empty bottles are going to the one on the right and drop into there. And we're going to start here at this piston, and it's going to let them go out one at a time.
Okay, so this bottle's half full, right? So,
Which means it's going to be directed this way.
all right. And this is
We
a
have a full, so that
bottle.
means he's going to go through.
right. So
And they
this,
drop into our bin.
yep. Okay, cool. And so empty bottles are directed over towards the robot.
Which that will get hit by the proximity sensor and let the robot take over from there.
Yes, when this proximity sensor goes off, it lets the robot know to go into sequence and to come get the bottle.
Okay, all right. So Tom, can you explain your PLC over here? What's happening?
Yes. I'm mainly doing I have the whole conveyor belt system. So you can see in that machine, Roman, can you please open up back?
Yeah. Here's the variable frequency drive.
There are 10 VFDs that control each of these 10 conveyor belts. So I control all those, and I had to basically trace the wires through this system into this bin. And then within this electrical cabinet, I have all the wiring I need for the pneumatics and VFDs. So they go into my ControlLogix PLC. It's by Alan Bradley, and he uses RS Logix 5000 software, which uses ladder logic. And basically I have my inputs and my outputs, so that when I hit the sensor, it's sent as an input, and then the software figure out what it wants to do with that input, and then shoots the appropriate outputs. So if I wanted to, I could have one input, fire 50 outputs, but in this case, I only need one. So that goes through the software and then decides to open this for 2.5 seconds, and then it'll close. So it's on a timer to let the bottle pass through, and then it shuts till, possibly have a half bottle be redirected to where it needs to be.
Okay, great. Okay, well, let's look over at the robot program and see how this works. So second PLC controls this robot.
Yep. And rather than a standard robot controller, we're running a PLC. And standard robot controller would make the robot move based on positions, and the PLC will have the robot move based on logic. So we have the proximity sensor to let the robot know that a bottle is there. And when that sensor goes off, the shoulder will move up and the gripper will open simultaneously. And then when that's finished, it'll run into the next of the sequence. So basically what I have here is all these different timers that will turn on when one timer's finished, next one will start, next one will start. And the timers, while they are timing, it'll run the outputs of all the motors to go forward or reverse in the different axes of the robot.
Okay, great.
Then when all of the timers are done, after the base is done moving counterclockwise, it will, when that is finished, all of these timers will reset, and it'll then wait again for another input from the sensor that a bottle is there, and we'll go grab another one.
Okay, awesome. All right, terrific project. Good.
Thank you very much.
Good job. Yep. Wave, Tom.